Okay, we'll continue our discussion with literals. So first is number literal. Now, a literal is a constant value that appears directly in the program. So for example, the following numbers, 34, 1 million, and 5.0 are the literals in the following statements. So, kaning sa int I is equal to 34, ang 34 dere mao na ato ang literal. So in this case, long x is equal to 1 million. So, we have that as our literal. Okay, then finally we have double D, which is equal to 5.0. So we consider these three values as number literal. Now there are two types of literal. We have integer literals and our floating point literals. Now integer literals, again, integer, what an integer means is these are whole numbers, okay, meaning wala sila'y uh, wala sila'y fractional part, okay, so they could be negative, so of course they could be positive, so they are considered as an integer as long as wala sila'y decimal part, okay, so kanang point something something, so kana wala sila nga na. Now, an integer literal can be assigned to an integer variable as long as it can fit into the variable. So, ibot pasabot ani. Okay? They're actually similar to how we have types of numbers. Okay? Napod tayo mga data type in which they could hold integer literal. Okay? Now, I have discussed this earlier or in our previous chapter. So, these are actually our byte, int, and long. Okay, so muna ang mga integer na to ng mga data type. So int, byte, int, and long. So as we have discussed, okay, let's go back na lang, okay, para makita ninyo. So going back to our kani, okay. So kaning first, we actually have four, okay. So we have byte, short, int, and long. Okay, so these four data types are considered as integer data types, meaning they hold whole numbers. Ang nakalainan na lang din sa ila is ilahang range of values nga ma-accommodate. So from the shortest or from the smallest range or size to the largest size, so mga na. Okay, now that is what it meant by here. An integer literal can be assigned to an integer variable as long as it can fit into the variable. So murarag katong analogy nato nga if magbutang tag usa ka litro worth amount of liquid sa usa ka baso, of course di na maigo tanan. Okay, so naay overflow ana nga matawag. So in this case, a compilation error would occur if the literal were too large for the variable to hold. So for example, the statement byte b, okay, is equal to 1,000. So mag-overflow na siya. Nga naman, a byte could only store pila man. Okay, it could only store from negative 128 to 127 nga range. So nang lapas na, okay, so sobra. So it would cause a compile error if you are trying to do that in your program, because 1,000 cannot be stored in a variable of the byte type. So you need to use, okay, the appropriate nga data type. Okay, so you could use short, so taas-taas iyang value. We commonly use int. Okay, we commonly use int since most of the time, okay, enough na iyang range ana. But if dili, so we still have long. Okay, long nga data type. So I guess I have discussed in the previous part the reasoning why you need to be mindful kung when to use int, when to use long, okay, when to use short, when to use byte. Okay, but again, during the duration of our discussion or in this course, most of the time when we're talking about integer data type, okay, int ato ang kasagara ginagamit. Sa kana. So an integer literal is assumed to be of the int type whose value is between, so kana. So to denote an integer literal of the long type, so sometimes gusto nato nga iparehas sila og sukod. Okay? We want that both we want to force integer literal to be of long type, meaning mas dako ato ang range nga gusto gamiton. Okay? So aside from declaring it to long, ayan data type, okay? Well, let's see. Let's try. If Java, okay, pwede na, okay? Ato. Okay, so kana. So we could append, sumpayan nato. Okay, similar to how we have I demonstrated to you how we force a floating literal to, I think wala pa. Sa kani. So to denote an integer literal of the long type, sumpayan na nato og letter L. It could be big or small, but the larger or the capitalized L is preferred kay kung L ato ang isumpay ana, pwede siya nga ma-mistake sa digit nga 1. Okay? So for example, ingani. So public class, okay, long literal. So public static void main string args. So let's say, let's try declaring long x is equals to 234 L. System.out.println, okay, x. Okay. So what happened here? Okay, it declared, okay, or it utilizes, or it is for the number 234 here is forced, even though maigo yun na siya diri sa to ang x as an integer variable. Okay, but since we declared it to long, okay, we could force 234 as a long literal. Okay, so if we remove that, okay, still the same kay of course there's no problem storing 234 sa ato ang long nga variable kay dako man kay na ang range sa ato ang dako kayo ang storage capacity sa ato ang long. Okay, so if we try int y is equals to 300, so let's see if mugana ni. Okay, so still mugana na siya. So this is the reason why most of the time we use int if you're dealing with small numbers. Okay, so kana kay doing this will allocate unnecessary amount of memory location sa to ang RAM. Okay, so since may raman tong number and we are dealing with small numbers, okay, which are larger than byte. Okay, so int is a safe data type to work on integer nga mga values. Okay, so kana. So floating point literals, so mao ni silang literal nga naay fractional part. Okay, so floating point literals are written with a decimal point. So by default, a floating point literal is treated as a double type value. Okay, so there are actually two types of floating point literals or floating point numbers in Java. So mao na itong ginatawag nga to. Okay, so natong ginatawag nga float o double. But by default, ang treatment sa ato ang mga decimal values, it is treated as double. Okay, so by default, a floating point literal is treated as a double type value. So for example, 5.0 is considered a double value, not a float value. So sa may kalahian ani silang duha, okay, we'll see later. Okay, so you can make a number a float by appending the letter F and make a number double by appending the letter D. Okay, so similar to how we append L, okay, to force an integer literal to be long. So kani pwede po nato nga ang decimal number pwede nato i-force nga F or D. Okay, so it could be a small letter or big letter, F or D. Okay, so for example, you can use 100.2F or 100 with a small f, or 100.2 with a big F. So, kana. So, ang kalahian nila is double type are more accurate. Okay, makita ninyo na nga more accurate na siya kay mas daghan ang iyahang i-allow nga decimal places. So in this case, ato ang double will allow up to 16 digits. Okay, so as you may have known, okay, the more accurate, okay, a decimal value is, the larger its digits are. Okay, murag mas gamay ang gipang round off. Okay, so parehas ani, if you're going to compare it here, okay, mas gamay ra iyahang digit, okay, mas daghan nga round off. So posible nga na i-rounding off na hitabo, okay, para sa na magamit ta og pi, di ba? Most of the time we use 3.14159, but it's not really the most accurate value of pi, mas taas na siya. But most of the time, okay, if we are computing mura basic lang nga mga geometric shapes which involve pi, okay, so pwede na siya. But I think in more sensitive, more complicated nga mga computation nga dapat accurate yun, of course, mga accurate na gyud na nga mga values sila ang ginagamit. Okay? So if we're going to try this out, so let's copy this. So let's make this floating just to be consistent. Okay, so I think this will cause an error if ato alang ning pasagdan nga ing ani. Let's try. Okay. So is it correct? 1. Okay, depende man god sa compiler, Java compiler. You might need to use parentheses to force computation to be performed first. So let's have the calculator here. 1.0 divided by 3.0. Okay, so okay ra. So kani. So by default, okay, 1.0 and 3.0 are treated as double data type. We know kay daghan, taas. More or less 16 ka digits or decimal places. But if we're going to, okay, if we're going to append F here, meaning gusto nato ipamubo ang iyahang accuracy. Okay? So if we're going to do that, actually diri gina siya mo effect diri sa to ang actual na computation diri. Okay? So we now force this to be float. We're going to execute that. Okay? So mas mubo na. So if we're going to copy and paste just to compare, okay, so as you can see, mas taas ni siya. Now, what are the reason why we want a number to be stored as a float? Again, one reason is for to save resources, to save memory allocation or memory space. Since if you only need to store that, or if you're contented enough to store that number or that value as a float, hindi lang kita sa accuracy, then what you can do is you force that by appending that here, then you assign that to a float nga variable kay para dili dako yung memory allocation compared sa ato ang double. Okay, so if you want to be efficient in your work, but you should only do this if it really warrants you to store only in a float nga format. Okay, or float nga range of values, data type, when it comes to Java. So I hope you get the idea here. Now, there are cases in which sa inyong Java nga computation, you get to see this type of result. Okay? Kanang naay E. Naay E, then kani. Naay E, naay E and 2. Okay? Or naay number. Okay, this is usually shown in this format. Okay? Naay whole number diha, decimal part, then naay E. Then naay negative or positive nga mabutang, either 2. Okay, positive 2 is same with this here. Okay, and kani is negative. Unsay buot pasabot ana. Okay, this actually Java shows scientific notation in this manner. Okay, I hope you already know how to read scientific notation. So for this case, in this example, tingala mo, sir, unsa man ang E? Is this the same with 1.23456 No. Okay? That is an entirely different number since natay ing ani. So this is actually similar to this number here. Okay? The E here stands for the exponent. Then ang 2 is, we could say, pila ka buok, in this case, unsay movement sa ato ang decimal point. Since this is positive 2, ang movement sa atong decimal point, gikan diri is duha. So, 1, 2. That is why, natay 123.456. Okay? But if it's negative, okay, ang movement sa to ang decimal point ana is to the left. Okay? So, that is why, negative 2. So, 1, 2. So, kana. That is how scientific notation is being represented in Java. So, in case mabantayan ninyo na, okay, that is that. Okay, next we'll be talking about augmented assignment operators. So, augmented assignment operators, these are a shorter way of writing certain equations. Okay, so normally when we perform basic arithmetic operations, so we have two operands in between an operator. Okay, so like when we add two numbers. Okay, okay, so let's say we have for this example, if you want to divide this number to another number, you'll notice na atay duha ka operand. Okay, and you have an operator in between. Okay, so normally we do that. Okay, so in every equation that we have learned so far, okay, mo minimize kina siya, or unsay tawag ani, it will be decomposed until we arrive with such scenario in which we have two operands and one operator. Okay, so mao na to ang normal nga pag-evaluate. Okay, but in programming, okay, there are ways to shorten that. Okay, so when later on when you become proficient in your programming skills, okay, pwede na mo makagamit og augmented nga assignment operator. So for now, just the basics, just to let you know that there is such notation in programming, okay, or in this case in Java. Okay, but I think this is true to almost all programming languages. Okay, so we have this operator, okay, plus equal, minus equal, asterisk equal, or okay, asterisk equal or multiplication equal, okay, division, then modulo or remainder equal. So kana sila, okay, these are just a shorter way of writing. Let's say for this example, I plus equal 8 is a shorter way of writing I is equals to I plus 8. So you might be wondering, sir, asan na siya magamit? Okay, usually magamit na siya when we later on when we talk about loops. Okay, if you want to update a certain value of a variable, okay, pwede na siya. So what happens here, remember, an equal sign in programming, okay, in general, is used as an assignment operator. It's not used actually as an equality operator. So assignment mean, okay, so when we see this equal operator, Okay? May tabo na is whatever the computation on the right side, iyahan nang store as a value na mabutang dere sa ato ang saman, ito ang left side. Okay? So kung unsay resulta dere, iyahan nang ibutang diha. Okay? So let's work on with that example. So let's say we have public class, let's say augmented operators. Okay, so public static void main. Let's transfer this here. String args. Okay, so let's say we have value of int I is equals to 0. Okay, so we declare a variable, we assign it with an initial value of 0. So kaning 0 dere, it is assigned using this equal sign, or we need to have a variable name, okay, or an identifier for a variable. Okay, so kaning 0 na to, mabutang na siya dere sa I as its value. So if we do something like this, I plus equal 8, it's actually the same as doing it like this. Okay, I is equal to I plus 8. So say pasabot ani, okay, kung unsay existing value in this line, okay, in this line in your code, kung unsay existing value sa I, okay, i-add nimo sa 8, then ang iyang new value would be the total value of this equation here. Okay? So in this case, let's change this para makita gid nato kung unsa ang iyahang himuon. So unsa may current value sa I ani nga stage? Okay? So we have the value 5. Okay? So 5 plus 8, so in this line here, okay, mahimo na siya og pila man 13. Okay? So if you do that in this notation, okay, ingani na yung itsura. So I plus equals 8. So how do we check that? So let's print that out. So let's kana. So if you're going to execute this, so you'll see okay, dapat natay semicolon diha. Yes, you get to see 13 ang iyahang value diha. Okay? So again, kasi malibog mo ani ako ning gibutang sa kana. So I plus equals 8 is it updates the current value of I. Okay? The current value of I is 5. Okay? It increased that by 8. So 5 plus 8 is 13. So to check if parehas ba gyud ning kana, so let's uncomment this, then ato aning execute. So expected, that would be 13. Okay, so that is the same with all the rest of the operator. Okay, so if you're going to do that with the minus operator, so sa may mahitabo ani. So what will happen is kung unsay current value sa I, i-minus niya og 8. So 5 minus 8, that will actually result to negative 3. So if ito na execute, okay, negative 3. So if ito na i-multiply, okay, so kung unsay existing value sa I, which is 5, i-multiply niya na by 8. Okay, so 5 times 8, mo na din ang new value sa to ang I. So that would be 40. Kana. So if we divide, since we are dealing with division in which in cases nga naagid na yung mga non-whole numbers, so let's define this as double. So, kana. So if you're going to execute that, so nana siya nga number. Okay, then if we have modulo, So that is the same with, okay, unsa gani ng modulo, so that would get the remainder portion of the division. Okay, so I is equals to I modulo 8. Okay, so unsa may I modulo, unsa may I 5. Okay, in this stage 5 divided by 8, pila man na, that is actually ang remainder ana is pila man, that is 5.0. Okay, kahit di man na ninyo, it is the same as 0 remainder 5, so you are going to get the 0 remainder 5, you're going to get the remainder portion. Okay, so mao ni yung augmented assignment operator. Okay, so for now di pa kay ninyo ni ma-appreciate iyang gamit, but later on when we deal with loops, okay, and other programming constructs, makita nato ni. So increment and decrement operators, again another way of writing equations in a different notation as we knew normally katong sa operand operator operand nga format. So kani mas mubo gini. Okay, now this is used if you want to increment or decrement by 1. Sibot pa sa increment or decrement. Increment, increase, decrement, decrease by 1. Okay, so if you're going to, okay, so let's say, let's change this, increment, decrement operators. Okay, so we have here, we actually have two variation for each increment and decrement. Natay post, natay pre and post. Okay, so nana siya gamay nga difference sa ilahang behavior. Okay, so when we say we have, okay, plus I, okay, so anang plus I, iyahan ang gina-increment by 1. Kung unsay current value sa I, okay, iyahang increment by 1. So if we're going to system.out println, oops, we're going to print I, the output would be, okay, oops, system.out.println, okay, wrong spelling. Okay, so you should be careful with that. Okay, so as you get to see, 6. I'm going to change this to int. Okay, para mag-coincide the rest of the example. So wala pa na ito gi-assign ha, we just increase the value of I. So if you're going to, this is the same with, okay, this is the same with having an augmented operator nga I plus equal 1. Okay, kay parehas naman na sila aning I is equals to I plus 1. Diba? So you essentially just added 1, the value 1 to the existing nga value niya. Okay, which is at this point 5. So if ato aning execute, okay, I always forget that semicolon. Okay, so 6 gihapon na. So parehas na sila ani. Now this is only used if you are incrementing or decrementing value by 1. Okay, so mas shorter ni siya sa augmented operator, but you need only to add or decrease by 1. So mao na kalahian na niya. Now unsa may kalahian anang, okay, post ug pre-increment. Now if you're going to use it like this, okay, let's say we're going to change that by plus. Unsay kalahian ana? Okay, in this manner wala na sila kalahian since parehas na sila nga ga-increase og value sa current value sa tong variable by 1. Okay, but ang kalahian ana nila is when you are going to assign it to another variable. Okay, so let's say we have int j is equal to plus I. Now what will happen is it will increment the variable by 1. Okay, so ihang i-add and use the new var value in the statement. Okay, so kung unsay value ani nga bag-o, mao na iyahang ibutang nga ato ang value sa ato ang iyang assign nga value sa j. So we have two variables here, I and j. So let's make this 1 para mag-coincide sa itong example dere. Okay? So kani nga stage, okay, at this point, okay, ang value of I here is actually equal to pila man? 2. Okay? Kay unsa may value, unsa may gihimo ani? Okay? So it essentially increase the value of I by 1, and the current value of I is 1, so 1 plus 1, 2. Okay? Now since we are using preincrement, okay, iyahan nang i-assign nga value kaning 2 sa ato ang j. Thus, okay, j is equal to 2. So if ato anang i-print, if we're going to print out j, ata na lang. I'm going to do it like this para makita ninyo sa atong program. I is I. So ato na ipakita ang I. System.out.println j is j. Okay? So ato anang kana. So if you're going to make this run, expect that we have I is 2 and j is 2. So if ato anang sakto, di ba? So the difference would be if you're going to use post-increment, okay? Ang mahitabo ani is still I is equal to 2 kay ani nga stage, di ba? As you could see, as you have seen kanina, okay? It regardless of if it is pre or post increment, it will always increase the value of I here by 1. Ang kalainan na lang dayon is kung unsay value sa j. Now what will happen here is it will store the original value of I. Okay? It will store the original value of I sa ato ang j. So what will happen here is value of I is still 2, but since you are using, okay, post increment, okay, kung unsay may original value sa I nato, okay, that is actually 1. So the value of j here is it would be 1. So if ato anang i-execute, okay, I is 2, j is 1. Okay, so mao ra nang kalahian. Okay, so the behavior is same when we use decrement. So predecrement. So tong predecrement, okay, so unsa may value sa I ani, okay, so value of I, we decrease the current value of I by 1, so 1 minus 1 is 0, so that would be 0. Okay, then ang atuang j, since we are using predecrement, so kung unsay value ani sa I, okay, ang iyang new value sa I, iyan ang ibutang sa j. Okay, so j would be equal to 0. So we're going to execute this. Kana, I is 0, nara output ria, I is 0, j is 0. Okay, but if you're going to use post decrement, okay, still the value of I would be 0. Okay, 1 minus 1 is 0. Okay, but the value of j, ang iyang value ana, okay, would be using the original value of I, which is 1. Okay, so if ato nang execute, okay, you could then see I is 0, j is 1. So I hope you get the difference here. Okay, kana. Again, this would be used more extensively when we talk about loops. Kana. So as you get to see here, this statement, okay, in this example, this statement here, kaninga linya, is essentially the same as writing 2 lines of code nga ingani. Okay? So kaninga linya, kani. Okay? So mao na ang iyahang kalahian. So as you can see, na-shorten gyud ato ang code. Okay? So using increment and decrement operators, okay, makes expression short, but also it makes them complex and difficult to read. So kung wa gyud mo kabalo kung unsay mechanics ato, posible malibog gyud mo. So avoid using these operators in expressions that modify multiple variables or the same variable for multiple times, such as this. So medyo libog yun na siya. And sometimes it becomes impractical. Okay? Even though you are trying to shorten your code, but if it becomes very complex, okay? So in a way nga lisod na siya basahon, then it would be very impractical. Okay? But anyway, na may mga use cases ani dili man gyud ingon nga gihimo lang para lisod-lisoron or pa style lang sa code. So there are specific use cases for this. So assignment expression and assignment statement, so mao ni ako ang gi-emphasize earlier, okay? So all the expression can be used as statements. So katong gihimo kanina as you've noticed, okay? So kani nagamit ani, okay? So we have used this ingana kana ana. So numeric type conversion. So I have demonstrated to you, okay, katong casting, okay? So katong nagamit ta og parenthesis, let's say double then close parenthesis to temporarily change the format or data type for that variable or for that value. Okay? So consider the following statement. So byte I is equals to 100, long K is kana, double D kana. So we have we use appropriate data types for certain specific data. So kung sa tong sa numeric, we are really concerned with just 2, okay? Generally 2 kung naa siya decimal point or wala. Now, when performing a binary operation involving 2 operands of different types, so binary operation, that is the same with having katong akong ginaingon nga naay 2 operands, 1 operator. So mo na binary operation man na siya. Actually kada sa math, all of it will come into a point or will arrive to a point nga mag-binary na siya. Okay? So you arrive with 2 operands and 1 operator. Diba? If you simplify an expression, diha man gyud napadulo until you arrive with 1 fixed value. So before you arrive with that 1 value, okay, ang step before ana is actually a binary operation. Now, if one of the operand is double, the other is converted into a double. So, ano yung rule? We will demonstrate this later. Probably, libog ni sa inyo hang step dire, but we'll try and demonstrate that later. Otherwise, if one of the operand is float, the other is converted into float. Otherwise, if one of the operand is long, the other is converted into long. Otherwise, both operands are converted into int. Ang buot pasabot ani, naani siya level of conversion nga unsay ay prioritize. Okay? So let's say we have kani. So conversion. So let's change the so conversion rules. Okay, so let's say we have system dot out dot print ln. Okay, so we have, let's say, 5 plus 3. Okay, so these are actually 2 integer values. Now since they are 2 of the same type, expected nga ayang output ani would be of the same type. In this case, integer value. So I'm using loosely integer here. I'm referring it to it as whole numbers. Okay? Kaya pwede man ito ning i-treat nga pwede na siya byte sir kay 5 naman or 3. Okay? But as a number, naturally we consider this as integer value. So let's execute this. System.out, sige gyud karong spelling ana. Okay? So 8. You'll notice yung treatment ana is whole number kay wala siya decimal. But if we change this, let's say ana, even though 5 and 5.0 are essentially the same value, but kani siya nahimo ani siya og, okay, since na siya 0.0, na siya point sa to ang siyang format, this could be considered as a floating precision point or a double or a float. Okay, so if we're going to execute that, okay, you'll notice, okay, na convert sa man na siya nga rule. Okay, So let's say if we treat this as a float, okay, if one of the operand is float, the other is converted into a float. Mao na siya. Okay. So how about this is actually the same with double, okay? So float and double, remember nakalahiran raman sa ilaha is ang ilahang precision or iyahang number of decimal places. So let's say we treat this as a double, okay? So let's say na. Okay? So what will happen is, okay, it will change this into a double. Okay? Sa ato, balik ta atong float. Wala na ako gipakita kung unsay gihimo niya sa weakest number. Okay? So when you do it like this, okay, di ba? Mo ning result. I'm going to execute this again. 8.0. Okay? Now in Java, what happens really is ihan ang i-convert nga naman. Java would only allow, okay, computation of the same data type. Mao na iyahang rule. But in order for us programmers not para mura bitaw mas mapasayon sa tuwa, Java, okay, sa iyang mechanism ani, okay, iyang built-in nga murag behavior is iyaning i-implement. Okay? Now in this case, you are trying to add, okay, let's say we treat it as a double. Double plus int. So dili na siya pwede, strictly speaking. Kay sa Java dapat parehas sila. Okay? So what will happen is since one of the operand is double, okay, it will convert the other, it will try and convert the other operand into double. So if mahimo niya na, so mahimo na siya double plus double. So what will happen is mahimo pud na siya 3.0. Okay? Even though we didn't write that sa to ang code, but once we compile and run our program, iyahan ang gihimo. Okay? So that is why mahimo na siya og 8.0. So mahitabo ana, okay, once we run our program, nahimo na siya og 5.0 plus 3.0. Even though wala na to nagisulat diha. That is why we have this statement here. Of course, if you're going to change that to 3.0 manually, parehas na sila og result. Okay? Muna siya. So that is the reason why iyahan ang i-convert kay dili pwede i-perform ang calculation nga different. Okay? Ang treatment different ang data type. Okay? So if one, okay, let's say one is float, okay, and the other is double, okay. Let's say we write F here and we write D here. Okay, to force that this is a float, this is a double number. So if we're going to execute that, okay, it will convert it to, as you get to see, it's a double. Okay? So if ito anang i-float, well, let's try if pwede ba na siyang execute. Okay, as you get to see, di ba? Since one operand is double, what will happen is, so gamitan tatong gi-example kanina. So float plus double initially atong gihimo. So if we're going to do that, okay, what will happen when we run our program, it will convert, Java will convert during program execution kani siya into double. So mahimo na siya og double. Okay? So pwede na siya i-perform. So what will happen is, okay, it will arrive with a value nga double. Okay? So I hope you get that. Tomorrow na ang meaning ani. Okay? Ihang i-prioritize ang double. What if, sir, long? Okay? Unsa gani nang long? It's actually a larger capacity sa to ang integer nga data type. Okay? So, if one operand is long and the other operand is double, okay, iyahang i-convert into double. Makita ninyo ni ang behavior or you will observe nga it will convert the other variable depende kung unsay pinakadako ang capacity. Okay? Double actually has the highest storage capacity. Next is float, next is long, finally we have int. Mao na siya. Okay? So if we're going to have, let's say, double na siya. Then let's say we have one is long. So long could only be a whole number man. So let's say 53 long. Nga na. So this will have it's long plus double. Since one of the operand is double, iyahan nang i-convert to double. Mas dako mag-capacity ang double kaysa sa long. Okay? Based on these rules here. So what will happen? So iyahan na i-convert to double. Okay? So, of course, di makita sir gamay ra man lagi. Of course, gamay ra man pud ni ang mao ra man pud ni ipakita. It is just performing 53 plus 3 di kung unsay sumpay diha iyan ang gihimo. Okay? So how about if atoan ang himon, oh no, not that. If atoan ang himon nga, okay, if you're going to force this into float, okay? So get to see, okay? Since we are using here float, so what happened here? So long plus float. Okay? Since here, if one of the operand is float and the other since we deal with long and float, since mas dako ang capacity sa float, okay, that would be the other variable we converted to float. Okay? So even though kani siya, this is actually a double nga value, but you writing f, you are somewhat rounding this off, okay, to the capacity of a float. So between long and float, okay, ang iyahang value or ang pinakadako nga capacity is float sa 2. Okay? So that would become float plus float. So the value will be a float value, which is kana. Okay? So that is true with any binary operation, division, multiplication. So din na ko na i-demonstrate. Okay? So that would be your conversion. Now, another conversion, okay, that could happen in programming is casting. So we have, okay, implicit and explicit casting. Okay? So katong ato ang gi-demonstrate, okay, in which ang conversion na hitabo during program execution, we treat that as implicit. Okay? Implicit casting. Okay? So another way of forcing casting or implicit casting is ingani. Okay? This is type widening. Nga naman, okay, even though, okay, you declare a variable d as double, but you store an integer value 3. Okay? What happened here is during program execution, this will be converted permanently as a double nga data type. So if we're going to casting, okay, para lang consistent ta sa to ang labels. So ito is that 3 double. So let's have it int d is equal to 3 sa. Okay? So there's nothing wrong here. It's natural. Okay? We store 3 as an integer data type. So pwede ra. If we're going to print that out, okay, there's no issue here. If we're going to print that out, mapakita to is 3 without any decimal point. But if we're going to change that into double, what happened here is, since you stored an integer here, okay, there's no problem here. Walay problema ani nga naman. You are trying to store a data type which could be accommodated by another data type nga mas dako og capacity. Now, since imuha ni siyang gi-store kaning integer nga 3, you store that to a variable d with having a double data type, iya himuon na siya, okay? Case during program execution, iya nang himuon nga 3.0. Okay? How do we see that? If we're going to print that out, okay? We're going to execute that, 3.0 na iyahang i-print. Okay? Now, what if bali? Okay? What will happen if gibali ninyo? Let's say, nagbutang ta og int d, then, okay? So, kanina, wala may problema, di ba? If we're going to execute this, 3 nang pakita. But if we're going to add 0.0 here, even though essentially they are the same value, but then again, you are using 0.0 here, so this would become a floating precision number, okay? Or a double or a float number. So ato nang execute, okay? Mag-ingon na din siya og incompatible types, dili pwede. Okay? Nga mga sir, ngano ganiha pwede between int to double but not double to int? The reason is again capacity. Okay? You are trying, okay? Int is less than double. Okay? Ang iyang capacity. So capacity. Okay? Mura ni siya og let's say you have the same analogy with having a cup to a is less than a liter. Diba? Of course. So if you're going to store, kung punanay lang, okay, kung punanay, if you're going to store a liter to a cup, di gina pwede muawas gina. Okay? Information will be lost. Mo na problema ana. But if bali, okay, let's say if you're going to do it like this, if butang nato ang ay na lang, okay? So if you're going to assign, okay, a double or an integer, okay, an integer to a double value, magproblema nga naman kay mas dako man ni ang capacity sa double kaysa sa int kung regardless if, di ba, remember sir, wa man ni napuno 3 is not the maximum value of an integer. Remember, when you allocate variable in your computer, in your program, okay, it would be allocated sa iyang maximum capacity sa iyang memory. Okay, since the program is assuming that you might be using the maximum capacity, so naniguro na ang program ana. Okay? So problema ni siya. So dili ni pwede. Okay? But if you have double, okay, you are going to assign the value an int value to a double variable, pwede na siya ngano man kay ang usa ka puno nga cup, okay, if ibutang ninyo na sa litro, walay mayabo nga data, walay mawala nga data, or walay information nga mawala. Okay? Imagine kanang mga liquid in its entirety is the information, which includes the integer part, the decimal point, and the decimal part, or the fractional part. Okay, katong after sa decimal. Okay? So, walay mawala. Okay? Kay mas gamay man ang capacity sa cup sa ato ang liter. So if you're going to store, okay, the contents of a cup, a full cup, nga puno gyud to an empty liter, okay? Pwede ra. Okay, walay mawala. Okay, so mao nang analogy ana niya. So what happened here, okay? What happened here? So kaning ani nga pagsulat, okay, is implicit casting. Nahitabo siya during program execution, and specifically it widens the type, meaning from a smaller capacity to a larger capacity, from integer to double. Okay? Muna nahitabo. Explicit casting is you into your code, you write that explicitly in your code. When you say explicit, okay, but pasabot na is kita tanan. Mawbitaw nang kanang sa mga rating, kanang sa mga movie rating, kay nata explicit content kay naay mga contents nga gipakita gyud. Okay? So normally to an audience, so naay uban yung mga bata or mga sensitive, dili ganahan ana. So dapat kabalo sila nga nahingana nga rating. But anyway, when we talk about explicit casting, but pasabot ani is part of your code, okay, you force that to be converted. Okay? So para sa ni int I is equals to int. So how do you cast explicitly? Okay? Mao ni, you write this. So in this case, okay, since you are storing the value I of having a data type int, okay, dapat ang mabutang raana is integer. Dili ka pwede makabutang og na decimal part. Okay? So in order for you to do that, you need to cast it, okay, into int. So of course, pwede na dayon kay parehas man sila nga data type. Okay? So kanina dili pwede ning ani. Okay? So int I is equals to 3.0. If we're going to print that out, kana di ni pwede kay you're trying to store a larger capacity to a lower capacity nga int. Okay? Incompatible. But if you want really to store that, okay, you could, nga na. So you casted. Okay, you convert this to an integer. So ato nang execute, okay, so pwede na. So this is just a very simple or a very straightforward approach. Okay? So you could actually do this. Okay, let's say ani ha, y is equals to 3.0 plus 5.0. Okay? Of course, this would be double. Okay? So double y, so pwede na y kasa na What if, okay, what if you want to store y to I? Okay? So nga na. There would be a problem here. Okay? Essentially, what this y is of double value. Okay? Double man iyahang gihimo dere. So if you do it like this, okay, magproblema. Okay? Double into an integer I. So, you need to cast that like this. So, 8. Walay problema, nahitabo really. Naa siya walay error, okay? And wala po logic error. But, doing it like this, okay, let's say 3.5, 5.1. What do you think would be the output? Okay? Now, when you're trying to convert or when you're going to cast, okay, a decimal number to an integer, it would retrieve the integer part of that number. Okay? The fractional part is truncated, meaning muragi chop-chop. Okay? Regardless kung unsa na siya 9, 8, 5, 6, iyahan ang kwaon sa iyahang number. And it will only retain the integer part. So when we talk about when we deal with decimal numbers, natay integer part which is the number before our decimal point, and ato ang fractional part is the number after our decimal point. Okay? So kaning decimal along with the say tawag ani fractional part would be truncated. Okay? So if we're going to run this, okay? Ato asa ni i-comment ha. Let's comment this out. Then we print y. Okay? So itsura ani 3.5 plus 5.1 pila man na? That is 8.6. Okay, 8.6. So no problem here. But if you're going to truncate that, okay, or ato na lang aka na. So 8.6, we are going to convert that to an integer. We're going to cast it to integer. Kaning 0.6, okay, which is actually the value of y here in this stage, in this line of code, would be truncated. Di na siya, it is different from rounding. Dili na siya ma-round. Okay? Putlon yun na. So, bahalag 4 na siya. Okay? So, this would be 8.9. Diba? So, what happened? Diba? 8.9 na siya. Okay? 8.9. Wala pa na ako i-print ang I ha. Mao ni ato ang isunod nga ipakita. What happen if you do it like this? Okay? Iyahang putlon ang 0.9. Okay? So if we're going to execute that, okay, 8 yang itsura. Okay? So that is, okay, fractional part is truncated. Okay? That is actually type narrowing. Okay? From a double, a larger capacity value to a lower capacity ng variable. Okay? Kana. So this, you should be very careful of this. Okay? Normally, you do not do it like this unless it is really intended nga integer part lang. Okay? Kaya this would cause a logic error. This could be considered as a logic error depende sa inyong problem. Okay? So what is wrong with this? Okay? Unsay problema ani? The problem with this is, okay, even though this is a valid operation, 5 divided by 2.0, you will arrive with a decimal number. Okay? Of course, it would become, okay, remember the conversion rule. One is double, the other And if the other operand is not double, the other operand will be converted into double. So mura ni siya 5.0 divided by 2.0. So that will be 2.5. But since you are assigning it to a variable nga x without casting, this will cause an error. So let's see ha. So int x is equals to 5 divided by 2.0. Okay, maman siguro to. So int x is equals to 5 divided by 0. Okay, this will cause an error. Okay, this will cause an error. Okay, incompatible types. Okay, nga na, may problema. So how do you solve this? Okay, you could solve this, okay, by changing this into float or double, I mean. Okay, pwede put float, okay, but I'll be using double. So kana. So you will have no, not I. So balik na to ha. Wala may I di I, di ba? Wala I. So kana. Okay, this will cause an error. Okay, incompatible type. If we're going to change this into double, ay hara tayo mawalang error. Okay, nga na. 2.5. Okay, so you should be very careful with that. So again, just a reminder, from byte to double, the range increases, and you need to take note of this when you are performing casting or even when you are performing operations in Java. Okay, kana. So keeping 2 digits after decimal points, write a program that displays the sales tax with 2 digit after the decimal point. So this is one way. Well, let's see if na hatag ko ba nag-appeal. As an example, lecture notes, ITCC 41 slide, sales tax. Well, let's check. Okay. Okay. So there are two ways really in order for you to convert, okay, or to perform an operation in which the final answer will have 2 decimal point. Okay, it's not always the case. It's not always the case nga ang gusto makita is daghan kay nga decimal point. Okay, normally we round it to 2 to 3 decimal places. So in this case, 2 decimal places. So we have this code here. So atoan na lang nang i-encode daan. Or let's write that in our compiler here. Okay. So import Java, since we want this program to accept user input, that is why we'll be using this scanner. So public class sales tax public static void main string args. Scanner input is equals to new scanner system.in. Okay, so a prompt here asking for the purchase amount, print enter purchase amount. Then we have a variable that will store that, since we are using double purchase amount. So ato ang user input would be, of course, the name of our object. Input is dot next. So double man itong gigamit diha, next double na siya. Okay, kana. So now we have that. So let's say we have a tax, double tax. So ito ang tax is purchase amount multiplied by 0.06. So let's say 6% interest. So, so sticking to our example here, one way is using, so far we have been using print ln sa to ang print out, sa to ang display. But there is another way of printing, that is printf. So for example is sales tax is, now what happened here, okay, sa to ang print ln nga method is walay rounding off mahitabo ani. Okay, so there's no rounding off, iya lang giputol gyud taman sa 2 decimal places. Okay, so no rounding off. Ito na lang ibutang diya since pa man to ang example. So int tax times 100 divided by 100.0. So mana, this is 1. Okay, so di sa nato i-type ang usa. So we're going to execute this. Okay, so let's wait. Okay. Again, okay, if you are going to use JDoodle as your compiler, you need first to enable the interactive button here. Okay, para mawala tong error. Okay, so enter purchase amount. Let's say palit ko og tag 50. Okay, 50 nga butang. So sales tax no rounding off is 3.0. Ang iharang i-compute ani isang interest. Okay, so that would be purchase amount times 0.06. Okay, so 3.0. So let's try another value. So 50.75. Okay, so ang sales tax ana niya, okay, so man ni thread Java input mismatch. Scanner input. Line 8. Why? Let's try and execute this. Ano mag-error siya? Oh, let's say 550.25. Why did it cause an error if 75? Okay. Siguro na lang ko yung na-click. Okay, go. Anyway, 50.75. Okay. I might have entered a space or a character there which caused an error. So kani. So 50.75 nga na. If you're not going to, okay, let's say we're going to create or display the line nga walay ingani. I'm going to execute this. Say 50.75. Okay, as you get to see, sa kaning line, okay, so sa kaning line, okay, wala na to gigamit nga murag conversion, okay, or murag kana, we could call this as a trick or unsay tawag ani, murag a workaround, okay, for you to arrive with 2 decimal places. So kanilang wala na to na gihimo ni kanina ay int then kani times 100 divided by 100. okay, iyahang i-display 3 decimal places. But take note, there is no rounding off nga naman. Kaya if ato anang i-round off ang 3.045 to 2 decimal places, that should be 3.05. Okay? So 3.045, if you're going to round that up, that should be round that off, that should be 3.05. But in this case, kani siya nga stage sa tong code, wala niya gihimo. Iharang gi limit up until 2 decimal places. So if you want nga na rounding off nga mahitabo, then you need to use the other type of printout, which is actually a more flexible way of printing or displaying information sa tong Java. Okay? System.out.printf. Okay? F stands here for formatted printing. Okay? So natay mo rag mas flexible ni siya actually. So sa ato ang code here, sales tax is, okay, so rounded nga sales tax, mas mubo ni siya, but na siya lahi nga way of writing. F tax. So makita ninyo ni immediately. Okay? So lahi, use the F here. Then you, di ba, if you'll notice here, we are actually concatenating unsay value sa tax. Okay? Ato ang isumpay dire nga text here. Okay, you're merging to string or text variable. But in this case, the value of the tax here would be printed. Kani dire, okay, the same, but since you're using printf here, dapat na siya ay murag placeholder dire. Wala na ni siya. If you notice, comma ang gigamit. Okay? Ang buot pasabot ani is, kung nakay variable nga gibutang diha, mangita na siya og part sa inyong string nga ginatawag na siya. You could actually do that here. That is actually kani. Okay? %f. So there are actually, when using, you could search, okay, we'll discuss this later, okay, printf modifiers, okay, these modifiers mauni pwede nimo mabutang as part sa string nga iyahang pulihan. So kaning %f, that is actually used to store double or kanang decimal nga mga numbers, okay. Now, if you want to specify a decimal point, number of decimal places, namo idugang ani. So, if ato aning himuon nga yung ani, okay? Ato asaning i-comment ha. So that we'll focus on this example here. So, if you do it like this, let's say 50.7, no. Wala ang dot. 50.75. So, sige to see, okay, sakto, okay, 3.045. Float, this is, in this example, we used float here. Let's search for modifiers. Print F modifiers in Java. Kanay. If you want to use decimal, okay, pwede, dali ra, diba? You search on Google. Decimal. Okay. So you could actually use, or you would use F for decimal floating point. So walay D for double. D is decimal integer. I think this is not, well, let's try. Okay. If we're going to use D here, oops, did I? Well, let's try. So 50.75. Okay. Dili ni siya, this might be misleading kay we treated D double, okay? D here sa printf is not really treated as a double, as a decimal number, but an integer. Okay? That is why we use F. Okay? So wala man yung problema kanina. Now, as you get to see, the result is, the result here, 0.75, is daily 2 decimal places. Okay, let's wait for it to execute. So we'll discuss more of this later. Kaning printf modifiers. Format specifiers. Still naghang siya. Let's execute. 50.25. Main medyo buggy dining online. 50.75. Okay, sometimes it will cause an error, sometimes it will not. So I suggest i-double execute na ninyo to be sure if nagi error or wala. So as you get to see here, okay, it's not 2 decimal places. So one way of specifying that is writing 0.2. Okay, so for now, just leave it like at this nga mao na ito himuon. Okay, we'll discuss more about printf format specifiers or modifiers later. I forgot the term here, but there are certain letters that you could use para ihanang kung ahan ibutang kung namoy gibutang if you want to display that variable here, dapat na siya ibutang diha kay if wala di po niya na ipakita. Okay, so we're going to execute this 50.75. okay, so you get to see na round siya and 2 decimal places. Okay, kaya if wala na, ito ang reason ha, let's say naanad mo aning print ln, okay, which is a different method. If we're going to do it like this, okay, so you get to see wala siya gipakita. Okay, dapat naamoy murag mahulog nga representative sa iyang string dere. Okay, ana. Okay, so that is your example here, or problem here. So casting in an augmented expression. Okay. Okay. So similar rules follow. Okay, if you're going to again, the way or the reason why dili na ko ni discuss in details kay di pa man nato ni magamit yun na augmented expression since we are not using loops yet. Okay, so let's just try na lang. Okay, let's try this sa iyang example here. So public class casting augmented public static void main string args. So int sum is equal to 0. So sum plus equals to 4.5. Okay, so what happened here is the value of sum will become 4 after this statement. So if you're going to 4 without the decimal point, system.out.println, if you're going to print out sum, okay, execute. Okay, 4, okay, without decimal place. Since this is actually the same as having it like this, sum is equal to int sum plus 4.5. So nitabo ani is ihaning gi-perform. Okay? So in this step, this becomes a double value. So mahimo na siya og 0 plus 4.5. But since gicast nimo siya into int, so mawala ang 0.5, then it would become 4. So that makes sense. So computing loan payments. So I'll be naman I think there is computing loan. Kani. So kamo na ako ang ipa-code siguro ani just for you to try this out, okay? This is very fairly straightforward naman. Kana. So it only involves basic operation. Okay, natay mat.pow, no? Natay mat.pow. So mat.pow, ang iyahang syntax sana is you pangitan yung comma first, okay? So that you'll know unsa ang base ug unsa yang power. Medyo kuan siya nga computation, no? Medyo complex, but just try this out na lang. Okay? And you understand, you try and understand unsa ang iyahang mechanism ani pag-compute. But other than this, straightforward man ang iyang expression evaluation. Okay? Here, you are displaying the results sa kadtong 2 decimal places nga dili rounded, na may mga instances nga dili i-round. So kana. So I'll let you try this. Then let's discuss the common errors and pitfalls in programming. Okay? So you might have noticed this, even me, when I demonstrated, okay, na yung mga errors nga manggawas. First error is undeclared or uninitialized variables or unused variables. Okay? So in this example here, this is assuming this is the same file or the same class. So double interest rate is equal to 0.05. Double interest is equal to interest rate times 45. What do you think is the error here? The problem here is you are actually using an undeclared variable kani. Ano man? Sir, na-declare mo na. Take note. Okay, this follows the correct convention. So capital letter ang second nga. First letter sa second nga word. But here, again, Java is case sensitive. Lahi ang treatment sa capital or sa small letter. So, this is an error here. This will cause a compile error. Okay? Next is integer overflow. Okay, you are trying to store, even though it's of an integer nga value, but you are trying to store that into a container, okay, or in a variable or data type, even though integer na siya nga mas dako. Okay? So, mag-overflow na siya. Similar to how when we attempt to store byte nga data type nga more than 1 to 8, or let's say we store byte x is equals to 200, it will cause an integer overflow. Okay, so it will result to this number here, of course negative. Sir, ano positive nga, so nag-error na siya. Round of errors, so kani, so more like this is a logic error. Okay, kay you might be expecting a number nga ingana iyahang format, but what would appear is entirely not really far off that number, but naay problema sa pag-rounding na dayon. Okay, so you expect that to be number nga ingana, but dili di ay ang itsura. So let's try that. Okay, so errors, programming errors. Okay, is that common error na lang? Common errors. So unsa to na? Ito na lang demonstrate. Uninitialized. So if you're going to double interest rate with the capital letter R, 0.05. So double interest is equal to interest rate, okay, times 45. So let's say if you're going to print that out, system.out.println interest. So this will cause an error, okay. Okay, so cannot find symbol but pasabutan na wala niya na nakita ang interest rate. Okay, so to correct that, okay, you change that to what you have used here as your declaration. So if ito na execute, okay, ninggawas na itong output. Next is integer overflow. So if we're going to have int value is equals to 214748367 plus 1. Okay, this is essentially the same as for 8, but i-emphasize lang diri nga natay sobra nga value. So if going to print that out, okay, so kana this is an integer overflow. Next is round off errors. So print 1.0 minus 0.1 minus 0.1 minus 0.1 minus, so pili man ka 0.1, 1, 2, 3, 4, 5, 2, 3, 4, 5. Then put tayo system.out.println, oops, 1.0 minus 0.9. Semicolon. Okay, so kani you might expect that the output would be kani, but it would really get that. Okay, so it's not really an error per se, but what you expect to be rounded off. So nga na, diba, it makes sense nga no, kinahanglan ko pa man ni kwaon gyud, unless it is intended, okay, pwede ra na siya. But cases are na ay mga instances nga na ay mga sayop sa tong computation or tong treatment sa ang data. Iparehas po dani. Okay, instead of having rounded it off to 0.1, okay, iyahapag yung inganion. Okay, so unintended integer division, kanay. Okay, so let's have int number 1 is equals to 1 is equal int number 2 is equal to 2. So double average is equal to number 1 plus number 2 all over 2. Let's print out the average. Print ln average. So what would be the problem here? Ang problema ani is, okay, 1 plus 2 divided by 2, that is 3 divided 1 plus 2 is 3 divided by 2, that should be 1.5, diba? Okay, so this is similar to how we on what we encountered earlier, okay, nga gakawala ang atong decimal point nga gusto na unta naa. Okay, so what happened here is you are dealing with integer here, you are dealing with integer here, so integer plus integer all over kana. Now even though this is a valid operation, since you are dealing with 3 types of integer, the same data types in your operation, pwede ra, but mawala to ang ato ang fractional part. Okay, so murada ka tatong gi-demonstrate bitaw na 5 divided by 2. Okay, mawala ang 0.5 since you are using integer. So kana unintended integer division. So the solution for that would be Okay, let's try this. If this is the solution, you change one of the operator into a double. If you doing this, unsa to ang conversion rule? If one of the operand is, what I mean earlier is operand. If one of the operand is a double, the other would be converted into double. Okay, so ultimately this would be evaluated into a value, in which case that would be an operand in itself. So this would become, whatever the result here, would become a double. So 3.0 na din siya divided by 2.0. If we're going to execute this, okay, 1.5. So correct na. So that is your unintended integer division if, okay, you perform a division with an integer value and you store that, or and you're dealing with integer operands initially. So problema na siya, or that is a error. Then redundant input object. So common yapon ni siya. We are using input object to accept, okay, to accept user input, di ba? So di ba, how do we do that? Dapat natay import java.util.scanner. So mga gina siya pinakauna. Next is, okay, let's say we have this. So scanner is equal scanner input is equals to new scanner system.in. Okay, once you created the object for our scanner, you need not create another one to store another input. Pwede na nito gamiton kani man ang input pasabot ani. Okay, input objects. Okay, so let's say we have system.out.print enter an integer na. Okay, so int v1 is equals to input dot next int. So wala problema na. The problem here is if you are going to create another object for another input. So input 1 is equal to new scanner system.in. Now this will run normally, but this is an error. This is a programming malpractice kibali, or it's an impractical way of programming. Okay, kaya you are unnecessarily creating objects nga hunahunahon pag yun sa memory. Okay, the same analogy sa ato ang variable. Now when we declare that, okay, it would be managed by the memory sa inyong computer. So this is an inefficient way of managing your memory. Okay, so let's say magbutang ta og print enter a double value. Regardless of type, all input type or all an input object should only be created once. So double v2 input 1 dot next double. This will, I think this will run normally. Okay, ito na lang nang i-display na lang be. So here, no, system.out.print, ito ay display ang v1 para na siya mahimo. Diri pod ito po ay display ano, system.out.print v2. So if you're going to make this run, so enter an integer 1. Actually na display ng 1. Let's print ln para next line siya. Ito na yung stop sa. Okay, 10. So that is integer 10. So okay, enter the integer value So you might notice, sir, wala may problema. Wala problema. Okay? But you used a solution which is inefficient. Okay? So that is a pitfall. Okay? It's not really an error, it's a pitfall. Mura bitaw it's a malpractice, it's a bad habit. Okay? Nga inyohang na-develop. The correct way of doing this is ingani. Okay? You need not do this. Okay? I-delete ninyo na. And you use that. Okay? So if we're going to execute this, okay, 10, display niya 10, 10.5, sa ba ni? Siguro nag-bug na po niya nga to ang koan. So 10, input. Sakto ba? Okay, 10.5. 10.5. Okay? So, as you get to see, parehas ra ang output, okay? Parehas ra ang iyahang gipakita dere, but this is more or less an efficient or a correct way of solving this problem or using input ng mga objects. Okay? So that ends our discussion with chapter 2. But what else can I add in this chapter? So you might be wondering, how do we accept user input nga dili number? Okay, let's say string. Okay, I think wala ni siya napakita dere. You can do that by, okay, ingani ra, sayan ra. Okay, so let's say we have, create sa tag scanner, ako nang na-erase. Scanner input is equal to new scanner system.in. Okay, so let's say mga tanan siya, enter your name, system.out.println, enter your name. Then you have string. You might have seen this here. Okay, that is actually a data type. Okay, but this is a non-numeric data type. This is the reason why wala din nag-discuss siguro dere kay focus ni sa numeric na data type. But if you are curious how to store a number or a value nga dili sa numeric, which is words nga na, string na siya nga data type. So string name is equal to input.next. Kana ra, next. Next or next line. Parehas na sila. So ana. So to anang i-print out system out.println. Okay. Hello. Name. Ano lang. Okay? Ito na yung common error. String input. So if you're going to execute this, so enter your name, 1. So hello, 1. So kana. Paman. So if you have questions, okay, feel free to ask sa sa corresponding video ani sa YouTube, or you can send me a message, or much better if you're going to post a comment. I think na may comment section dayon ning nga material resource ato ang class. So kana. So I think that is all. So I will end our discussion for chapter 2 here. So kana lang. So see you next video for another lecture discussion.